Welcome to lecture series 8051 microcontroller. In today's session we will discuss about addressing mode. The addressing mode, what it will define based on the instructions how we are using for the data transfer, arithmetic, logical and some other jump branching instructions, we are using some instruction format, right. So, based on the instruction format they have derived the addressing mode. The addressing mode, what it will define how the operands are specified in the instruction. Okay. It is not specific for either data transfer or arithmetic, it will be combination of all. It will take any one of the instruction, how the operand is specified in the given instruction. If it is an operand or it both, how we are using in the instruction means some mnemonic format, then register, along with that either data or address or something, right, or you can say it is an operand, some numbers. Sometimes we are using like that, or sometimes both are registers, or you can simply say move source comma destination comma source. So, what it represents, the data is moved from source to destination. Okay. So, based on this you can understand what is the specification of source, what is the specification of destination, both should be a register or both should be a data, is it possible. So, that way only they were specified the addressing mode types. Okay. So, the addressing mode which will define the various specification of operands in the given instruction. Okay. So, basically it have 4 types of addressing modes: immediate addressing mode, register addressing mode, direct addressing mode and register indirect addressing mode. So, based on the name itself you can get some understanding. Okay. Immediate addressing mode means some data is available, the data immediately or mostly we are using for the initialization purpose. Okay. So, move a comma some data. Then register means both source and destination are register. Direct means here we are using the address to specify the memory. So, the memory access related instructions will be used in either direct addressing mode or in the register indirect addressing mode. So, now we will discuss immediate addressing mode. Immediate addressing mode means here the source operand is constant. Source operand is constant means we are using the instruction format like move destination comma source. So, the data is always moving from source to destination. Here the source only we are initializing as a constant, that is it is nothing but a number that will be indicated by this symbol. Okay. So, the immediate data must be preceded by the sign hash symbol. So, along with that we can give any kind of data. Then the source is a data, destination is a register. So, what are the registers you can use? Accumulator can use it, B register can be use it, and the R0 to R7 any one of the registers you can use. Okay. The destination should be any one of the 8-bit register along with the source is 8-bit. Okay. So, based on that we are using the immediate addressing mode. Suppose if you are taking the example move a comma hash 25, the hash 25 represents it is a constant value in the source. So, you can directly say it is a immediate addressing mode, the given value 25 is loaded in the accumulator. The another one is the given data 64 is loaded or moved to the R4 register, that is why it is a immediate addressing mode. Here some value 40 is loaded in the B register. The fourth example is interesting one. Here what we are doing, 16-bit data. In 8051 only one 16-bit register is available for the general purpose. For the 16-bit data we are having the DPTR. In the DPTR we have a 2 8-bit register DPL and DPH. Okay. This is for lower byte and this for higher byte. So, after initializing this value, the 21 is loaded in the TPL and 45 is loaded in the TPH. Okay. So, this way only the 8 bits, 2 8 bits are loaded in the 16-bit register. This is the immediate addressing mode. Another one is register addressing mode. Here the source and destination both are registers and both should have the same size, then only you can use it. Both should be 8-bit register or it will be the 16-bit register. Example move a comma b. So, what it states, b is a source register, a is a destination register. So, the content is copied from b to a. The another example move r2 comma a, here the content of A, the source content is moved to the destination content which is R2. Add A comma R5 also a register addressing mode, because here source and destination both are the register. So, what is the meaning of this? Means the R5 is added with A and then the result also stored in the accumulator. So, based on this source and destination both are register, we can say it is a register addressing mode, direct addressing mode. So, based on the name you can understand the address is directly specified in the instruction. It is mostly used to access the RAM. In 8051 we have 128 bytes of internal memory. So, the maximum address is 7FH. Okay. The 128 which is 0 to 127, its hexa equivalent is 7F. Okay. So, among that first 32 bits reserved for the registers, then 15 bits is reserved for the bit operation, right. The remaining 32 7F only we are using for the address access. So, here only the number is used without specifying any symbol. So, take example move R0 comma 40 means the 40 is a number or operand which is not a immediate data, because there is no symbol. So, how the function is operate means the source specifying the address, the content of the 40 is moved to the R0. Suppose if we have the content 40, content of the 40 is 20 means after executing this instruction now R0 value is 20. Okay. Suppose if you are using move R0 hash symbol with 40 means after executing it R0 equal to 40. Okay. This value might be x or any value that will be moved, the unknown value is accessed. Okay. The memory content is read and stored in the R0, that is without any symbol the operand is given. This is represented as the address which is used to locate the memory. Another one, this is for the read operation, we are reading from the memory. Suppose if you want to write the data into the memory means we can get the accumulated data into the given address. So, this address is 56, whatever the accumulator value that will be loaded here. Suppose the accumulator value is 31 means here the 31 will be loaded. Okay. So, here the memory address can be sourced in used in either in the source or in the destination, but it is operand which is between the 30 to 7F. The address is directly specified in the instruction, that is why we call it as a direct addressing mode. The last one is register indirect addressing mode. So, what it represents here, the register is used to point the data or point what it represents to read the data. Okay. So, here we have a register R0 to R7, but only R0 and R1 is used to access in this way, which are indirect access, remaining are not used. Okay. So, the symbol, special symbol we are using before that, only R0, R1 and the DPTR also you can use it for indirect accessing. So, move A comma at R0 represents the content of the R0 is moved to the A. So, what it represents? Move R0 hash symbol 40 if you are using, what it represents, the content is 40. Okay. If suppose I am using move A comma at R0 means what it represents, the 40 become address, the content of the 40 only moved to the accumulator. Okay. So, here the 40 address, memory address is not specified in the given instruction, that is why we call it as a indirect addressing, but with the help of R0 we are using, that is why we call it as a register indirect addressing mode. Okay. The address is specified in the register indirectly, with the symbol at represents it is a indirect addressing. So, move A comma at R0 which is a read operation, we are reading the data from the memory. Okay. The same instruction if you are using move at R1 comma A. So, what it represents, the accumulated content is stored. So, this is for write operation. So, we can perform the read operation or write operation with the help of the register indirect addressing. So, the direct addressing and register indirect addressing both are the related with the memory, either you can read or you can write the data based on the source and destination. If the address is placed in the source, you can say it is a read operation. If the address is specified in the destination, we are writing, we are storing the data. Okay. Either we can read and write. So, these are the 4 addressing modes in 8051. So, based on the operand specifications we have classified as immediate addressing mode, register addressing mode, direct addressing mode and register indirect addressing mode. Okay. So, now we will discuss some program how to write it. Write a program to flash the LEDs in all bits of port 0 for 1 second, okay. Either 1 second or 1 millisecond you can take it. So, in that case what I am saying port 0 you are asking, right, that is why I am selecting the port 0, move port 0 comma all LEDs you are giving, all bits in port 0, that is why I have given all bits, okay, P0 comma all bits are initialized with a 00 value, then call delay. So, for 1 millisecond delay I will be called here for 1 second. Okay. So, at this time what will be happen? So, now I have a port 0 have a 8 bits, right, 8 bits are connected with the LED. This is a port 0, port 0.0, port 0.7. So, by giving this instruction what will be happen, all LEDs goes to off, move P0 comma 00H it goes to off. So, how long it will be off means based on the delay it will be for 1 second. Okay. Then now I am loading the next data, move P0 comma FF. After reading the value FF, now all LEDs will glow. So, it goes to on state. How long it goes to on means based on this delay. Suppose you are giving two different delay, then automatically on time will be increased than the off time. So, this also I have given the same delay. So, 1 second, then jump repeat, what it represents the same thing. So, automatically the LEDs on and off will give like a flash. Next we will discuss another example. Write a program to count number of ones and zeros in the given 8 bit number. Okay. This is a 8 bit controller which is in 8051. So, I have taken only the 8 bit number. Suppose I consider the number as 45. So, 45 means its binary equivalent in hexadecimal, each bit is represented with the 4 bit. So, you can write 0 1 0 0 then 0 1 0 1. Okay. This is the number which is in the 8 bit representation. Here I want to know how many zeros and ones. So, by counting the number of ones, ones is 3, zeros are 5. Now, I want to calculate this, how many ones and how many zeros. So, how will you get this? So, I have to initialize the two counter, one counter for counter 1 for zeros, number of zeros, counter 2 for number of ones. Okay. In the counter 1 the value will be loaded as 5, counter 2 the value will be loaded as 3. Now, I am starting and completing the process, then when the loop will exit, okay, or when the counter will stop means automatically I have to initialize one more counter which is to counter 3 for number of data 8 bits. Okay. So, I want to count the number of ones and zeros only for the 8 bit, that is why I initialize the counter. So, totally 3 counters I have to initialize based on your requirement ones and zeros with the maximum value. Okay. Now, we have to think what is the logic to count the number of ones and zeros. Okay. So, here we consider with the rotation, by rotating through the carry, whenever the carry flag is set I will count either in the 0 or 1. So, based on the logic we have written the program, you check it. So, move a comma 45, this is my data which you want to count the number of ones and 0. Okay. Then I have initialized the two counters R1 and R2 for number of ones and number of zeros. The third counter which is in the R3 which will define the number of bits. Okay. So, this will be considered as a counter to stop the program. So, 3 counters I have initialized, then I will start the work. First it depends on the carry, that is why I am clearing the carry flag. Initially I cleared the carry flag. Now, the accumulator content is rotating right. Okay. So, what is your value? 1 0 0 0 1 0 1. Okay. Rotating right means what will happen initially, right. So, this become it passed through the carry flag. So, it become 1, then it is rotated to 0, 1, 0, then 0, 0, 1, 0. This 1 rotating means it will be back, right. So, it become 1. So, now I am checking the carry flag bit position. Okay. After rotating the accumulator, now I am checking the carry. If no carry means what it indicates, it is a carry. This is for 1, this is for 0. If no carry means what it will do? It will increase the number of counter of 0. Now, the carry is set, right, because the value is 1. So, carry set means what will happen? The R1 will be increased. So, the R1 now initially in 0, now it become 1, then it jump to the end, then now the counter value. Okay. So, I will keep like R1, okay, R2, R3. So, R2 value is 0, R3 is initially 8, now it is reduced to 7. Now, 7 it is not 0, so I will move it here. So, again rotate it. So, by rotating here what I will get, the exiting value is 0, 0, 1, 0, 0, then you will get the value as 0, 1, 0, 1, 1, R1, R2, R3 I will take it here. So, 1, 0, now it is 8 becomes 7, right. Now, I will check it, the carry flag is 0. 0 means it will jump to here, now it will increment the R2 as 1. R2 value is 1 and this value will be decreased as 6. Okay. So, this is not 0. So, again go to the 1. So, here again rotating right. So, it become 0, 1, 1, 0, 1, 0, 0, 0. Now, it will become as 1. So, the carry flag is 1 means what will happen? It jump to here, right. So, the R1 become increased, R1 value already 1, now it become 2, then the counter value is decreased as 5, it is not 0, then again it started to rotate. Okay. So, based on the same process it will be repeated. So, again another one is 0, then 0, right. So, it become 2, then it become 3, another one is 0, then it become 4. At the same time I am decreasing this as a 4, 3, 2, then it become 1. 1 means it become 3, right. Now, it become 1. Another one is initialized with a 0. Okay. The same process repeated. So, I write only the carry flag condition. Now, it is 0, 0 means it will increase the R2 value. At the time after increasing R2, I come to this R3 value is 0. So, R3 value is 0 means what will happen? It will end. Okay. If it is not 0, then only it move to here. It is reach 0 means it will come to the end. So, now what are the values in R1 is 3, in R2 is 5. So, totally 8, okay, 3 number of 1s and 5 number of zeros. So, this is a way the program is used to count the number of 1s and zeros. The another program is how to write to calculate the x power n. Okay. To calculate the x power n. So, x should be 8 bit because we are using the 8051 which is a 8 bit microcontroller. So, you can take it any value, I will take it as 5, x equal to 5 power 3. Okay. 5 power 3 I want to calculate. 5 power 3 how we are using means 5 into 5 into 5. So, 3 times I want to multiply. So, this way only we are using the same concept. So, first value should be loaded, then you call the next time, then here for every multiplication the result is stored in the accumulator. Here the multiplication is performed via the accumulator and B register, right. So, here multiplicand you have to load it, here multiplier you have to load it, you keep in mind. Then the process is repeated and the result is after multiplying the result is stored in the accumulator and B. If any carries occur or the exceeding size will be loaded in the B register, the minimum value loaded in the accumulator. So, in this we will check, I have loaded the 5 power 3. So, the 5 is loaded in the accumulator, the n is loaded in the B register. Okay. for a simple repetition process, I temporarily moved to R0 and R1 process. The 3 is moved to R0 and accumulator 5 is loaded in the R1 value. The initial process, the number of loop, what it represents 5 times is 5 is 3 times we have to multiply, right. So, that time repeatedly we are using, at the time the counter value sometimes 3 become 2, 2 become 1, and one more time it will take it. So, to avoid that, I initially multiplied with 1 into 5. So, I will get the 5, right. Now, the accumulator value was, this is a accumulator value, this is a B register value, that is here what they have taken it as R2. Okay. So, these two values only repeatedly it comes to use it, then the R2 become A, or you can consider as a B. So, now the 5 B value become 5. So, 5 into 5 25, then 25 into, that is 5 into 25. Okay. This way only we are multiplying this process. So, first the value is temporarily moved 1, then move A comma R2 means what it represents, R2 value is 1. So, accumulator value is 1, then B value is 5. So, after that the accumulator value is 1, B value is 5, then I am multiplying 1 into 5, I will get 5. Now, I am decreasing the R0 value which is in the B, that is R0 is reduced as 3, 3 is reduced as 2, then the accumulator value is moved to R0 for the repetition process. Okay. Now, R0 is in the accumulator, what is the value of R0? 1. So, now this 5 will be moved, then B value is R1 value which is in the accumulator value. So, 5 into 5 we are getting, so you get it as a 25. Again the same process will be loaded, 25 into 5 which is 125. Its corresponding hexadecimal value only stored. For understanding, I have given the decimal equivalent. Then every time the R0 value is compared, every process it will be reduced, then 0. So, it compared with 0 0, whenever it reach the 0 it will exit from the loop. Okay. Then finally, now the result is in the R2 register moved to the accumulator. So, in today's session we have discussed about the addressing modes and some sample programs, right. In the addressing mode, what are the addressing modes, how the addressing modes are classified, right. The addressing mode mostly it is divided based on the specification of the operands. So, it is a register addressing mode where source and destination both are registered, and if the source is a data, the destination is any one of the 8-bit register or 16-bit register, then it is called it as a immediate addressing mode. Then the source or destination, any one specifying the address where the memory location, right. That is we are accessing via the memory in the RAM, either we can read or write, that kind is call it as a direct addressing. Instead of addressing, we are using either R0 or R1 with @ symbol, or simply you can say with @ symbol it is a register indirect mode, only the number is available, it is a direct addressing mode. With hash symbol the number is available, that is a immediate addressing mode. If both are registers, then it is called it as a register addressing mode. So, based on that you can understand how the program will run, okay. How many bytes are required to execute this, okay. Whether mnemonic word, then opcode also we are computing. So, during that time you can understand. So, this is a addressing modes. So, based on that we started to discuss the simple programs, how to count the number of ones and zeros, right, and how to find the x power n. So, x power n here simply we have given, right. You can, based on this you can find the number of squares and cube or anything you can calculate it. Suppose I am asking you to find the sum of squares up to 10. Okay. So, here what you will do, the x value will be varied, right. N value is 2, x value first become 1, then 2, then 3, then only you get 1 square, 2 square, 3 square, 4 square up to 10 square. Now, every time the value will be generated, the same program you can use it, and the result is stored in the R2, right. Now, I want to add the numbers. So, automatically you have to initialize the memory like in the DPTR, every sum squares will be loaded 1, then 4, 9, 16, 25 up to 100 you have to store it. After storing that, like a addition, you have to call each number and add it. Okay. So, the simple program can be used to obtain the n number of examples you can use it. So, hope you have got some understanding what is addressing mode and how to write the some addition programs, or how to generate the series, or how to find the power of any number. Okay, thank you.